Bismillahirrahmanirrahim. Atmospheric pressure. The pressure exerted by the atmosphere is called atmospheric pressure. Now, how we can prove that atmosphere is exerting pressure all around us? To prove this, we can do this simple experiment. I'll show the video of this experiment also. Before seeing that video, a practical video, let us understand that what we are going to understand from this. Actually, this is the experiment to show that the atmosphere exerts pressure. First of all, in the first step, you will have to take a tin rectangular can type thing, or you can take any circular or cylindrical can also you can take. This is a tin can. Say we have taken this tin can. This tin can has this small opening here. We have poured some water. Here, this is water. This is water in it. Now, in this situation, you can see that there is air inside and air outside also. So, air inside and air outside both are exerting pressure on the walls of this container. So, that is why the shape of the container is maintained because both the pressure outside, which is atmospheric pressure, and inside also, because air can enter in this can, and that's why that air is also exerting the same pressure. Whatever the pressure is from outside, the same pressure is from the inside, because on both the side there is an atmospheric pressure. So the shape of the can is maintained. Now in the step 2, what you are going to do, basically you will start heating this water. When the water will heat up, the steam will be produced. That steam, when the steam will be produced, that steam will push out all the air from this small opening. From this small opening, all of the air will be pushed out, and after some time you will see that steam will be coming out from this small opening. Now in third step, what you have to do, you will have to stop heating it, and you will have to close this small opening. You will have to make airtight. Now this container has become airtight. Now in this container there are two things. One is water and other is steam. Water and steam. Now because air has been pushed out due to steam, now there is only water and steam in it. In the fourth step, what you are going to do, you will have to pour some cold water on this container. When you will pour some cold water on it, what will happen? There was a steam inside. As I told you that you have closed this opening of the can. You have closed this opening of the can. So what happened? When you pour the cold water on it, the steam inside will condense, and that steam which will be condensed, it will become water again, and there will be a vacuum inside. So when there is vacuum inside, there is no air, no steam, because in this case also the steam was exerting a pressure from the inside and the atmosphere was exerting a pressure from outside. So that is why the shape of the container was maintained. But now when you have poured cold water on it, the steam inside has turned to water again. Now there is nothing which is exerting pressure from inside, but there is an atmosphere which is exerting pressure from the outside. That is why, due to this atmospheric pressure which was exerted from outside, this container has crumbled. So this experiment will be seen now. You can watch this video.
And it's part of the Year 9 science curriculum. Is what we're going to do is we're heating up a little bit of water in the bottom, and as we heat the water up, it changes phase from liquid to gas, and that gas fills that space, and all of the inside gets really hot. And then what we're going to do is we're going to switch the gas off, and we're going to close the lid, and we're going to put the hose pipe on. And what should happen is that because the volume expanded when it was hot, and then it changes back from water vapor to water liquid, it's going to create a whole lot of, it needs less space, and it won't be able to suck air in because the lid is going to be on, and then it's going to collapse in. So I think we're pretty close to being there. So maybe Mr. Hodgson and Mr. Briscoe, we can just take the gas out.
Hi, Miss Hatcher.
Here out of the way.
Guys, may as well start when he gets the hose out.
Stand your ground, free.
Now, as you told you that atmosphere exerts pressure everywhere. Now, how to measure that atmospheric pressure? To measure the atmospheric pressure, we use barometer. So, barometer is the instrument which is used to measure the atmospheric pressure. Okay, so here I have shown you a simple barometer. This is a container, small container containing mercury. It is open container, so you can see that atmosphere is exerting pressure on the surface of mercury. You know that the chemical symbol of mercury is Hg. So this container is filled with mercury, and from the top surface, the atmosphere is exerting pressure on the surface of the mercury. Now you will have to take a long glass tube, 1 meter long, about it must be 1 meter long, 1 meter 100 centimeter or 1000 millimeter. You have to fill this long glass tube with mercury. Also, as you know that while dealing with the dangerous chemicals, you must wear gloves in the laboratory. So now, keeping your finger on the opening of this long glass tube, you will have to invert this long glass tube into this container like this. After dipping the opening of this long glass tube into the mercury container, you can remove your finger. Now you will see that the level of mercury will drop in this container because it was filled. Now when you will invert this glass tube in this container, the mercury will fall down into this container, but whole of the mercury will not fall down. It will stop at a certain level. Why it will not completely all the mercury will not fall into this container? Because as I told you that from the top surface of the mercury, the atmosphere is exerting pressure. Now here, due to this atmospheric pressure, the whole of the mercury will not be able to fall in it. Okay, so because atmosphere is exerting pressure from the top surface, so this mercury will stay at a certain level. Now at which level it will stay? If you are conducting this experiment at sea level, then you will observe that from this level till the upper level of the mercury, this height will be 760 millimeter of Hg. This is the height of the mercury column if you are conducting this experiment at sea level at a standard temperature. Okay, so this 760 millimeter of Hg is called one atmospheric pressure. Okay, so how we are going to measure this 760 millimeter of Hg? So this is the atmospheric pressure in terms of mercury column. If somebody asks you that how you are finding out the one atmospheric pressure equal to 760 millimeter of Hg, so you can simply say that actually the 760 millimeter of Hg is showing that if the height of the mercury column is 760 millimeter of Hg, then this height of the mercury column is showing one atmospheric pressure. Now this one atmospheric pressure can be converted to Pascal. How we are going to convert this into Pascal? As you know that the pressure of the liquid can be calculated with this formula, rho GH. This is called rho, which is representing the density of the liquid which is being used here. So here we are using mercury. So the density of mercury is 13.6 gram per centimeter cube, or it is 13,600 kilogram per meter cube. Almost this is the value of the density of mercury. Now this is the density of mercury, G, small g, the value 10. It can also be taken 9.8. Okay, and the height of the mercury is 0.76. It is very important to know that 760 millimeter is equal to 0.76 meter. Now we have to apply in this formula while finding out the pressure of the atmosphere in terms of Pascal. You must use this in meters. Now applying the values and by calculation, almost it is round about 101,000 Pascal will be the atmospheric pressure at sea level. Barometer is used to measure the atmospheric pressure. Now you can see the simple barometer is consisting of a long glass tube of measurement 100 centimeter. Now this long glass tube is filled with dry mercury. We use the dry mercury in this glass tube. We pour dry mercury in this glass tube, and now we have to keep its opening closed with the help of a thumb. And keeping this opening closed with the help of the thumb, you will have to invert this long glass tube into the mercury container like this. Now you will observe that this level of mercury in the glass tube will fall down up to certain level, okay, up to certain point, and that will fall down almost, if you are conducting this experiment at sea level, it will drop up to 760 millimeter. So till this red line, and between these two red lines the distance will be 760 millimeter. And if we are conducting this experiment at sea level, so the atmospheric pressure at sea level will be 760 millimeter of Hg. Now here you can see that at the top of this glass tube the vacuum has been created because there was no air. This is called Torricelli vacuum. Okay, because this vacuum which is created, first invented by Torricelli, so it is called Torricelli vacuum. As the altitude increases, air pressure decreases. As the air pressure decreases, the mercury column in the capillary tube begins to fall. Thus, the Mercury Barometer is also used in finding the altitude or height of a mountain. In aeroplanes, barometer without mercury is used to measure the altitude gained